Hello there, thank you for joining me. My name is David Kidder. In this video, we're going to add some more phasors. We're going to be in quadrant 2. So quadrant 2 is up to the left. And what we have then is going to be a composite of horizontal components that are going to be a negative. And we're going to have vertical components that are going to be a positive. So this is the sort of the values that we have to deal with in quadrant 2. All right, so the first thing we've got to do is plot our phasors onto our HV chart and then solve for it, and then we will figure out what the new resultant current is. We got I1, 50 amps at 170 degrees. All right, and then we have I2, and that is 30 amps at 105 degrees. Okay, so really, it's just a matter of plug and play now. So we're going to take 50 multiplied by the cos of 170, and we get a negative 49.2. That's what we expect, as we are looking for the horizontal component, and we're to the left of the axis here. We are going to be negative on the horizontal. So negative 49 looks good to me. And we calculate the vertical, and we have 50 times the sine of 170, and we expect a positive 8.68. All right, moving to part 2, I2, which is 30 amps at 105. So 30 times the cos of 105, and I got negative 7.76. And times the sine, we get 28.9. Perfect. So at this point, all we really got to do is add up our horizontals and our verticals, solve for the new length as well as the angle. Okay, so we're going to take negative 49.2 and add it to negative 7.76. So we're going to get negative 57.9. We're going to take the verticals and add them together, and we will have 8.68 plus 28.9, and that is 37.7. Okay, so there we have our two new components of our resultant phasor, which is I total. So what we did is we basically solved for a new triangle, and we have 57.9 amps on the base. We got 37.7 amps on the vertical. All right, so use Pythagorean theorem to solve for our missing side, and that is the a squared plus b squared is equal to c, and we're looking for c here. Okay, so when we punch that in, we're going to get some values that look like this. We're going to get the square root of negative 57.9 squared plus 37.7 squared, and we will get 68.3 amps. Okay, so 68.3 is our new length. And we're going to call this I total. Add these two current phasors up and get the total between the two. All right, so our length is 68.3 amps, and what we got to do then is figure out at what angle. A phasor is two things, a length and an angle. So we have to go ahead and solve for what the angle is. Two things we could do. We can solve it with tan, the arctan. Okay, so the arctan is going to give us the angle between this degree here, which is 180 degrees, and our new phasor, and it's going to be a negative. So let's see what that looks like. So we have our vertical over our adjacent. So that's opposite over adjacent. That gets us our angle. And so when we put in arctan of 37 over negative 57.9, we have to make sure we have that negative in there. We're going to get negative 33.5 degrees. So that's a perfectly good number to use. It's the one I choose to use. So all you got to do is make sure that you know that you're off the 180 degree mark. And so we're negative 33.5 degrees from there. And that sits us at what actually ends up being 146.5 degrees. Okay, so we are 68.3 at 146.5 degrees. Okay. Now, if you use tan, it's very consistent across all four quadrants. You just have to know that. Instead of dealing with the 0, 360 mark over here, as soon as we're over in here, the tan function is going to work from this baseline, which is 180 degrees, and we had to subtract 33.5 off of it. All right. If you do the exact same function and you get a positive, you take 180 and you would add it onto 180. However, you can use the cos function, and the cos function, find a little room here, arc cos is adjacent over hypotenuse, so that would be negative 57. So the negative adjacent over our hypotenuse, which is 68, this would actually yield the correct 146.5 degrees. And now that will be only true in this quadrant. This is our cos quadrant where cosine will work and give us the right answer every time. All right, but I figured just stick with tan and you'll have a very consistent answer. All right, so break your phasors down into individual components, and seeing as we are obviously going to be negative on the horizontal and a positive on the vertical, we expect our new phasor to be somewhere up in here. That's I total, 68.3 at 146. All right, so I hope you enjoyed this, and we'll see you in the next one.